All right, today we're going to talk about something that secretly keeps our entire digital world from falling apart. It's all about how we take messy, tangled up data and turn it into something clean, consistent, and honestly, something you can actually trust.
So here's how we're going to break this down. First, we'll look at a super common data problem you've probably seen a million times. Then, we'll uncover the hidden dangers lurking inside it. After that, we'll get to the why, the simple rule causing all the chaos. And finally, we'll walk through the elegant solution that puts everything right.
So, let's kick things off with a situation that, it looks pretty harmless at first glance. But trust me, for anyone who needs their data to be accurate, this is a ticking time bomb.
We've all seen tables like this, right? With a little bit of repeated information. And you might think, okay, it's not super efficient, but what's the big deal? Well, does it cause any real harm? As we're about to find out, the answer is a huge, resounding yes.
Okay, just take a look at the data right here. You see that repetition in the rating and hourly wages columns? Every single time you see a rating of 8, the wage is 10. Every single time. This one simple fact is being stored over and over and over again.
And that repetition, it's not just about wasting a little bit of disk space. No, it's way more dangerous than that. It's actively creating these weak spots, these vulnerabilities. In the database world, we call them modification anomalies. First on our list is the update anomaly. This is what happens when you need to change a piece of that repeated info, and believe me, it is a recipe for total inconsistency.
And here's that problem in action. Let's say the company decides the wage for rating 8 is now $11, not $10. You now have to hunt down every single employee record with that rating and make the change. If you miss just one, like we did right here, bam, your data is instantly corrupted. Now you have 2 different wages for the exact same rating, and your database just can't be trusted anymore.
Next up, we've got the insertion anomaly. This one's a real head-scratcher. It's a structural problem where the design of your table literally stops you from storing perfectly valid information.
So, what if HR wants to create a new pay grade? Let's say a rating of 12 now corresponds to a wage of $25. But here's the catch. No employee has actually earned that rating yet. With this table structure, you can't add that fact. The table demands an employee's social security number to create a new row. You're completely blocked from storing a simple business rule.
And finally, we have the deletion anomaly. Now this one is maybe the most insidious of them all, because it means we can accidentally lose crucial information forever. Imagine your very last employee with a rating of 7 leaves the company. You do the normal thing. You delete their record. But look what happens. You don't just lose their personal data. You've also completely wiped out the fact that a rating of 7 corresponds to a wage of $9. That entire piece of the company's pay scale information is just, poof, gone, simply because the last person associated with it is gone.
So what is going on here? What's the root cause of all these nightmare scenarios?
Well, it all boils down to one fundamental database principle called a functional dependency.
Now, functional dependency sounds a little academic, but the idea is super simple. It just means that if you know the value in column A, you can uniquely figure out the value in column B. For example, if you know an employee's social security number, you know their one and only name. We'd say the name is functionally dependent on the SSN.
Okay, now here is the absolute key to this whole thing. It's the type of dependency that matters. When a primary key, like an SSN, determines another attribute, that's totally fine. That's how it's supposed to work. The problem here, the villain of our story, is that rating, which is not a key, is determining hourly wages, which is also not a key. This specific kind of problem is called a transitive dependency, and it is the single structural flaw causing all of our problems.
This brings us to the formal solution, a set of design rules known as third normal form, or 3NF for short. This is the principle we use to eliminate those problematic dependencies for good.
Yeah, the formal definition can sound a little intimidating, but the core idea is incredibly simple. A table is in third normal form if it has no transitive dependencies. That's it. It's a direct rule designed to kill that one specific problem we identified, a non-key attribute determining another non-key attribute.
And fixing this is a beautifully logical 3-step process. First, you identify the problem dependency. Second, you lift it out and give it its own separate table. And third, you remove the redundant data from the original table, leaving behind just a link. Let's see it in action.
Okay, here's our before picture one last time. The messy table with that transitive dependency just sitting there.
rating determining hourly wages, causing all of our problems.
Now, here's our first after table. The hourly wages column is completely gone. The redundancy has been eliminated. But, and this is critical, we've kept the rating column. That's our link.
And here's the second table we made, the wages table. This is where that relationship between rating and hourly wages now lives, cleanly and by itself. The fact that a rating of 8 pays $10 is now stored in exactly one place. And with this new structure, all three of those anomalies we talked about are now literally impossible. So we've fixed the table. But let's just take a second to recap why this organized approach is so absolutely essential for building systems you can actually rely on.
Now, there are even stricter rules out there, but third normal form hits this perfect, practical sweet spot. It ensures that even after we split our data into separate tables, all of the original business logic still works perfectly without any extra complications.
And the payoffs here are huge. By following this one simple principle, we eliminate redundancy, we prevent those dangerous anomalies, we protect our data's integrity, and we build a database that's way more flexible and ready for the future.
Because ultimately, when we make sure our data is clean and consistent with principles like 3NF, we're not just organizing ones and zeros, we are building a reliable foundation of facts. And that foundation is what allows us to move on to the truly exciting part, asking questions, finding insights, and letting that data tell its story.